Okay, so jot down these answers. You guys got this? EECBD, CBD, ADBAC. All right. Okay, let's check out number one. You guys, literally, it's all about the words because I was reading this and I was like, what? All right. Okay, when x equals 8. That's fine. I'll come back to that. The rate at which blank is increasing. When you see the words rate or increasing, that's a derivative, right? With respect to time? Yeah. Okay, so I'm going to write, because I'm like kind of confused right now, I'm going to just do this. This is what helps me. Meaning, okay, I'm going to take the derivative of that with respect to time in a minute. I'm going to do ddt of this. So that's just a way of writing. I am going to take the derivative with respect to time in 1 hot second. And we know that it equals 1 over k times the rate at which x is increasing. So again, it says rate, blah, 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 which, yeah, is the derivative with respect to time of x, which I'm going to do. Cube root x? Wait, you're confused by that? Sorry. What is the value of k? Okay, so basically, it took me a minute to think about this, but it's basically like, take the derivative of that with respect to t, take the derivative of that with respect to t, and one is 1 over k times the other one, right? So, you guys, do you remember how to take the derivative of cube root of x?
Yeah, because it's the same as x to 1/3.
Yeah, it's like x to the 1/3. 1/3 x to the negative 2/3. Yeah? Does that make sense? Yeah, so this is 1/3, and then x to the negative 2/3, I'm just going to put that on top. X to the 2/3, or third root of x squared, yeah. And I'm going to go ahead and put dx dt next to that one. And then this side's a bit easier because what is the derivative of x? 1 dx dt. Now, both sides have a dx dt, so I can just, like, cancel that out, right? So I'm left with this equation. Okay. Now, what am I trying to find?
So cross multiply?
Yeah, for sure, we could cross multiply. So k equals 3x to the 2/3. We could do that. And then how am I gonna like solve for k? It told me something else in the problem. Woo! So that's not too bad. Yeah, 3 times 8 to the 2/3. Now, do you guys remember how to do something to the 2/3? Remember that, okay, so like 8 to the 2/3 means 8 squared cube root. Now, you can do either first. 8 squared is 64, and if you know the cube root of 64, you can do that. Or you can do the cube root of 8 is 2, and 2 squared is 4. Oh, from the beginning of the problem, when x equals 8, right? So I'm constantly going back and reading the problem, like the beginning part, when I'm doing these, you know? So 8 to the 2/3 is 4. 3 times 4 is 12. Yeah, so, okay, when you have something like that, this is how, this is one way I used to teach this. It's called, like, in and out, right? Do we love in and out? I actually don't really like in and out that much, even though I'm from California. I mean, it's okay. It's not great. In and out. So you think about in and out, your favorite burger place, and that goes in the square root, and that goes out. So it just means the cube root of x of 8 squared. So you can figure out, like, which one goes where. So basically, the fraction on the bottom goes on the outside. That's your root. The fraction on the top is your power. Does that make sense, Sabrina? Well, and then do either one. You can either do 8 squared first or cube root of 8 first. What's the cube root of 8? Like what times what is 8? Yeah. The cube root of 8 is 2, and then 2 squared is 4. Okay? That one's a little tricky. This one is great.
Are you gonna do this one on
I did.
Not number 1. Number 2, possibly. Quite possibly.
Number 2 was easy. I did not do number 2.
All right, let's check it out here. Okay, so again, as I read, I write things down. The radius of a sphere is increasing at the rate of blah, blah, blah. So dr dt 0.3.
That's why.
I could write that. Okay. At the instant when the surface area becomes 100 pi, so surface area is 100 pi, what is the rate of increase of the volume? I'm looking for dv dt. Okay, so I got kind of a lot going on here. But since I'm looking for dv dt, I'm going to go ahead and take the derivative of that with respect to time. So I'm going to put 4/3 pi. Okay, the derivative of r to the third is 3r squared dr dt. And then I just have to start plugging stuff in.
But why did we use, I swear this one's not warm enough for winter time. It is so cold.
It's pretty cold in here. You want me to turn on the heater?
3x squared?
I mean r, but yeah. Because the derivative of r to the third is 3r squared, right?
Yeah. How did you, never mind.
And then dr dt is 0.3. Now here's the thing, you guys. I'm looking for dv dt, but I'm missing r, right?
Let's see where you put it.
So how do I figure out what r is? I got to go back and I got to use some information to figure it out. Now, what information on here have I not used yet? That's dr dt. Yeah, I haven't used this yet. And I figured, like, they probably told it to me for a reason, right? Okay, this is the surface area right here.
Radius is half the surface area?
Radius is kind of, it's 4 pi r squared of the surface area. So if the surface area is 4 pi r squared, and that's 100 pi, what can you tell me about that? If I divide by 4 pi on both sides, what do I get? Yeah, well, the pi's cancel out. 100 divided by 4 is 25, which means what's my radius? So it gave me that information specifically so that then I could then go find my radius and say, oh, okay, my radius is 5. And now I can do the rest of that problem. All right? Now, guys, if you notice, this is a no calculator question. Okay? So I have to be able to do all that without a calculator. Does that stress you guys out?
No.
Okay, just think about this, right? If I see like that 3, I'll cross that out. Okay, what's 5 squared?
5 squared?
Yeah,
25?
that's 25. That's 4. 25 times 4 is 100 pi. So this is 100 pi times 0.3. And what's 100 times 0.3?
30.
Yeah, 30. Yeah, so this is 30 pi. Okay? Yeah, but you gotta, like, even stuff like that, so get good at, like, reducing fractions and stuff, whatever. All right, cool. Was number 3 the one that you guys were,
All of them. I tried all of them. I couldn't figure them out.
okay.
Number 3,
This is really long. Number 3.
Now, typically with a cone, I have to do that special equation where I relate R and H and all that stuff. I usually have to do that. Yeah, we didn't have to do it this time. And the reason why is because it gave me literally all the information I need. Look, blah, 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 blah. Blah, blah, blah. The radius and the height both increase at a constant rate of that. So dr dt is 1/2, dh dt is 1/2. Okay? What rate is the volume increasing? So I'm looking for dV dt when the height is 9, so h is 9, and the radius is 6. So it gives me everything. So I just have to do the derivative.
You got it.
I got it.
So if I leave like the 1/3 pi out front, and then did you do a product rule on that part?
No, it didn't do a product.
Okay, because that's why r squared h. All right, so let me give you guys a second. If you haven't yet, go ahead and do the product rule on that.
Seriously?
2r dr dt h, do it for some second, and then first squared, so I mean, sorry, r squared the first, and then dh dt, okay? So that's gonna give me 2 times 6 times 1/2 times 9 plus 6 squared times 1/2. That's not that bad, right?
No, it's not bad algebra. It sucks, but it's
2, 2. The 2's cancel out, that's 54. 6 squared is 36, divided by 2 is 18. What the heck is 54? 50, 60, 72.
67. You know what's equal to 67?
27, 72, I mean, 2, 4. Yeah, 24 pi.
Got that right.
Yeah. Okay, that's a good one. That's a good one.
How did you get 18?
6 squared is 36 times 1/2.
6 squared, that's all.
Yeah,
Is that what I need? Equals 24 pi?
that's it. And we are chilling.
What about the 1/3? What is 1/3? Oh wait, 1/3 pi.
That's from the original formula.
And 2/3 is
Times
100.
72.
Yeah.
Is that what it was? They're kind of fun.
Objection.
Yes, they are fun. I like them too. Okay. Number 4. All right, now this is a little bit, let's just write down what it's telling me. The sides of a rectangle increase. So are any of these constant, or are they all moving? Yeah, because it's just like expanding or whatever. Okay, look, dz dt is 1. Now this is weird. We haven't really seen anything like that before, but dx dt is 3 times dy dt. Okay, I don't know what I'm going to do with that, but that's fine. When x is 4, y is 3, what's the value of dx dt? All right, already, can you guys tell me what z is real quick, since we...
3, 4, 5.
3, 4, 5, very good. You're going to have triples. Triples are good. Yeah. Okay, and then we're going to go, all right, x squared plus y squared is z squared. They're all moving, so it's 2x dx dt. It's 2y dy dt. And then it's 2z dz dt. All right. Now I'm going to fill stuff in. X is 4. Why did I not write? X is 4. What is dx dt? So look through all your stuff. What's dx dt?
dx dt equals 3 dy dt.
Yeah, which is like weird, but I'm going to go with it. So I'm just going to say, okay, times 3 dy dt. Okay? Plus 2 times y times dy dt, which I don't know, equals 2 times z is 5, times dz dt, which is 1.
Which is 1? How did you know?
Right here?
Oh, it's up there. Sorry.
Yep.
I was looking at the X.
Nope, we're good. All right, so now, 2 times 4 times 3, that's 24 dy dt. 2 times 3 is 6 dy dt equals 10. Combine like terms, exactly, because now we're back down to just both dy dt's. Okay, so that's going to give me 24 plus 6. That's going to give me 30 dy dt is 10. So when I divide by 30, dy dt is 1/3. Before you mark your answer, now this is true for multiple choice questions on the AP Calculus test, on the ACT, on whatever. You always go back and read really quick what you're looking for. What are you looking for? What's the value of dx dt? We know what dy dt is. You're exactly right. So we solved that whole thing. We got dy dt. Dx dt is 3 times dy dt. So what's dx dt? 1. I know, it annoys me too. At least it wasn't 0 or undefined. Okay. Ooh, I thought this one was so hard. Okay. I looked this up. I felt the exact same way, and I'm still not really convinced. But if I gave you this picture, okay? The spotlight ones just, they kill me. I don't know why. I just hate it. Boop, 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 boop. I'm not going to. I can't even do them. Person. The person is 2 meters tall. He's walking in that direction away from a streetlight that is 8 meters above the ground. Okay, the shadow is this right here, okay? And then, yeah, I don't like it either. And then the rate at which he's moving, they use like this right here. Wait, let me see. Yeah, they use like that as the rate that the guy is actually walking.
Well, we don't know either.
No, we don't. But we're going to use, okay, so check it out. Let's like call that Y for the shadow. Let's call that X for the rate that he's walking. At this point, you can make an equation with similar triangles. All right?
Okay, yeah.
So if I gave you that picture, maybe that would help.
X equals 2 over Y.
Yeah, except for this. Oh, that's a Y.
Oh, a Y. Okay, sorry.
I put a little tail on it.
Equals 2 over Y.
Okay. So yeah, if I've got like, my equation would be like 8 over, now it's side over the base. So I'm going to put 8 over X plus Y. Okay, equals 2 over Y. Just because that equation is a little bit crazy, I'm going to cross multiply before I do the next part. And so I basically get 8Y equals 2X plus 2Y when I distribute. And I can subtract the 2Y over, so I get like 6Y equals 2X. Now take the derivative of that with respect to time, and then we can figure it out. I did not like it, but it's basically just with a person and a shadow and stuff, you just have to do similar triangles. Yeah, so then it's going to be like, okay, so it's going to go like this. 6 dy dt equals 2 dx dt.
So dx dt is 4/9.
And yeah, the rate he's walking is 4/9. So that's...
Sorry, it's the shadow, so Y would be 4/9.
Oh, right. Yep, the 4/9 is what the shadow is changing. Okay, so 6 times 4/9 equals 2 dx dt. And I just divide by 2. 6 times 4 is 24.
So it's 4/3.
24 over 9. And if I divide by 2, that would be 24 over 18. And then if I reduce that by 6, that'd be 4/3. Yeah, I mean, that one I thought was really tricky, but there you go. It's similar triangles.
8/3 times, wait. That sucks. That freaking.
Triangle ones are tricky.
What now is it? 24, 18.
They're funky and they're weird. Okay, let's see if we can get through a couple more of these. Oh, I did. What did I do? 6 times 4 divided by 9, and then I divided the 2 over also. So when I moved the 2 over, it went on the bottom. I'm just doing like some number magic. Oh my gosh, let's go. All right. Guys, If the rate of change at x equals c is double the rate of change at 1, what is c? Okay, first of all, what is the rate of change of x? Rate of change means derivative, right? So it's 1 over 2 square root x. Yeah? dx dt. Okay? Do you guys get that that's the rate of change?
Yeah.
All right, so let's go like this. The rate of change at c, let's go ahead and plug in c. Don't know, that's what we're looking for. So I'm gonna put a c right there. Is double, so 2 times, and then let's go ahead and plug in the rate of change at 1.
Which is just 2.
Yeah, exactly. Which is 1 over 2 square root 1. Now, you see how the dx dt's can cancel out? Okay.
Wait a second.
Hey, where did you guys go?
So, yeah, so check this out. The rate of change here, when I put a c in, is double the rate of change here when I put a 1 in.
Ooh, okay, that's interesting.
Yeah, it's kind of weird, but I just was literally like following the words, right? Now, there's a dx dt on both sides, so I can kind of get rid of that. So 1 over 2 square root c equals 2 over 2, which is 1, right? Cross multiply. Okay, so like put that over 1 and cross multiply. So 2 square root c equals 1. How would you solve that? Square root of c is 1/2. So c equals,
1/4.
yeah, square both sides, 1/4.
Okay. Where did you get equals 1?
Yeah. Okay, so
I'm not gonna figure that out on the test. But
it's a little tricky. All right, are you with me until like until this?
2 times 1 over 2 square root of 1.
Oh, okay. So what's the square root of 1?
1.
And what's 2 over 2?
1.
Right?
Yeah.
Okay, so then what I did, because I wanted to cross multiply, I needed to make them both fractions. So I put 1 over 1, just to make it, my life make sense. And then I went like that, and then I went like that.
Oh, so you put 1 over 2 c dx dt equal to 2 times 1 over 2.
Yeah, exactly.
I thought you were like changing it to that.
Oh, right, no, I'm just setting those equal, and then I just followed that through, solve that. Okay? Okay, let's look at number oh, cool, we're almost done. Oh, we can do 4 more in 4 minutes. I don't know, let's see. The base of a triangle is increasing, so dB dt is 3. The height is decreasing, dH dt is -3. Which of the following must be true about the area? Oh, this was so tricky. I loved it. All right, check this out. You know area of a triangle is 1/2 base times height. Yeah?
yes.
Okay, so let's go dA dt equals 1/2. Now I'm going to do a product rule in here, okay? So what's a product rule for b times h? We would go derivative of the first times the second, and then the first times derivative of the second. Okay, we good?
1 second. Yeah.
Makes sense, right?
Wait, did you just put dB on?
Yeah, that's dB dth and then b dht. Now dB dt is 3, so that says 3h. dH dt is -3 minus 3b. And that's all the information I have. So I want to know if the area is increasing or decreasing or what. Okay? So just start making up numbers for b and h.
Wait,
Now,
how'd you get 3 in there? Oh,
because that's, yeah, dB dt was +3, dH dt was -3. So it's like the base is getting bigger at the same like rate that the height is getting smaller, you know? Is the area always increasing? Is this always going to be positive?
No.
No, because I could pick numbers to make it something else. Is it always decreasing?
No.
No. Okay, so then I was like, does it remain constant? No, it definitely changes. So I got it down to C or D as my options. And then because this A is decreasing, okay, so I picked numbers for B and H. I just picked stuff, right? So let's say B is less than H. Let me pick like...
Wait, question, why is B negative? Oh,
because DHDT, right? So I picked like 1, 2. Now, if B was 1 and that was 2, would it be positive or negative? 6 minus 3. Yeah, that would make it positive, and that's decreasing. So let me switch those around. So instead, let's say B is 2 and H is 1, because that one says B is bigger than H. 2, 1. Then it would be 3 minus 6, and it would be decreasing. Does that make sense?
Yeah.
So it's like kind of a thinking question. I don't know. I like that a little bit. I don't actually think we have time for all of these. Let me see which. I think I want to do 10 is the better one. But yeah, the most bestest. But I'll go back and do the other two and put up a video of them or something. We got this. The radius is increasing at a constant rate. dr, oh gosh, I'll get back here. dt is 0.2 meters per second. What is, oh, I'm on number 10. I skipped. Skip. What is the rate of increase of the area? What's dA dt? Equals question mark when the circumference is 20 pi. Okay, here we go. The area of a circle is pi r squared. dA dt is pi times 2r dr dt. All right, we're looking for dA dt. So it's pi times 2. We don't know r, and we know that dr dt is 0.2. Now, we don't know r, and so what do we do when we have something that we don't know? We go up to something that we had from before. The circumference is 20 pi, which is 2 pi r. So I can figure out r from that information. R ends up being 10. So then I can come over here, put in 10, and then you can figure out your answer then. And it was all because the circumference was 20 pi. Okay? Because circumference is 2 pi r, so you just work your way backwards. You know? Wow.